Hello everybody. We are going to move on to the subject Introduction to Instrumentation. So this is really related to the different measuring instruments that we'll be using in our day-to-day life, also in various industries and in many other such places, and how to handle them and how we are making use of those instruments for various measurements. So the subject code is 18MT504, and the first unit is general characteristics of a measurement system. So in this first unit, we'll be talking about the measurement system and about the transducers, different types of instruments, and the errors and responses on the various physical variables of this. So straight away, let us move on with the first topic for today. So generalized measurement system. So this is the flow chart for the generalized measurement system. So these are the various functional elements of an instrument system. So the first part is the physical variable that is to be measured, and that will be the input signal for the primary sensing element of a measuring system. And from the primary sensing element, after sensing the input signal, it will be transferred to the variable conversion element. From the conversion element, it will move on to the variable manipulation element. Manipulation element is like it is going to manipulate the signals. And then next is the data processing element. It will process into the required form. And the last one is the data presentation element, from which the output can be read or seen by an observer. So about each one we'll look in detail. So primary sensing element, that is the first element which will receive the energy from the measurement. That is nothing but what we are going to measure, and will produce an output which is converted into an analogous electrical signal by the transducer. Then the next one what we have seen was the variable conversion element. So it will convert the output of the primary, that is what we have received from the primary sensing element. It can be a voltage or a frequency, into the suitable form. So it is going to convert into a suitable form without changing any of the information content. So this conversion element is an optional one. It's not a mandatory element. The next element is a variable manipulation element. So it will manipulate the signal, and it is just like amplifying the reading and then showing it to the observer, but it will not change the original nature of it. So it just amplifies the input signal to required magnification. This element may also precede the variable conversion element. That is, first the primary sensing element, then the manipulation element, and after that the conversion element. So either way it can. Next is the data transmission element. It transmits the data from one element to other. Example like sharp and here. And then the data processing element. So it is going to modify the data before it is going to be displayed or it is available for the observer. So it is used for converting the data into the useful form and to separate the signals that has been hidden in the noise and provide the corrections to the measure. The last one is the data presentation element. So it is a final element which is going to communicate with the observer for monitoring, controlling, and for analyzing. The value of the measured variable can be indicated either by an analog indicator or a digital indicator or a recorder. So this generalized measurement system can be now clearly seen with an example. So the example that we are going to see today is filled thermal system. So this filled thermal system, so here we can see a temperature bulb which is being inserted into some liquid, or it can be even a solid or anything. So this temperature bulb is going to sense the temperature of the liquid or the solid or gas. So let us assume here as a liquid. So once it is being inserted into the input, so here our input is the temperature. The next part is the capillary tube, which is being followed by the spiral board-on tube, and then we have the linkage and gear mechanism, and finally a pointer and a scale, which is nothing but the presentation. So once again I tell what it is. So here temperature is our input. So we are going to sense the temperature. Then we have our capillary tube, and then we are having the spiral board-on tube, and then we are having the linkage and gear mechanism. So which is the manipulation element. Linkage and gear is the manipulation element, and finally the presentation element is the pointer and the scale. So this can be still clearly explained. So the physical quantity to be measured is going to be our temperature. So the temperature is going to be sensed by the primary sensing element. So the primary sensing element, and here there is no need of any conversion element. So both are the temperature bulb. So the primary sensing element and the conversion element. And next we are having our capillary tube. So the data transmission element, the pressure is transmitted into the capillary tube, and then we are having the conversion element, which is the spiral board-on tube. So the spiral board-on tube pressure gauge is the conversion element, and then we are having our linkage and gear, which is the variable manipulation element. So it is going to manipulate, or it's going to give it in an expanded form or like an amplified view for the observer, and then finally the scale and pointer, which is going to act as a data presentation. So the physical quantity to be measured is the temperature. So our temperature bulb is going to sense the temperature, and then it is going to be moved on into the capillary tube, which is the data transmission element, and then the spiral board-on tube is the conversion element, where the pressure is being converted, and then we are having the manipulation element, which is the linkage and gear, and finally scale and pointer is the data presentation. So the liquid or the gas which is being filled is being sensed by the temperature bulb, and then it is being converted into the pressure, and then the pressure is being transmitted into the capillary tube, and then once again it is being converted and manipulated and presented to the observer. So temperature bulb senses the temperature, which is input, and converts into pressure. Pressure is sent into the data transmission element, which is the capillary tube. The board-on pressure gauge converts the pressure into the displacement, and then the manipulation element, which is our linkage and gear. Displacement is being manipulated to get the larger point deflection, and finally the presentation element is our pointer and scale to give the readings to the observer, which is our output. So this is the first topic, our generalized measurement system. Next we move on to the simple topic, which is units and standards. So the very simple topic which we have learned even from the school days. So to specify and perform calculations with the physical quantity, the physical quantities will always be defined both in kind and its magnitude. Unit is a standard measuring of each kind of physical quantity. Example, we have the CG system and the MK systems. Next, SI is a standard unit system which we are following nowadays. So it is the International System of Units which was established by CGPM, General Conference of Weights and Measures. So SI is the system international units. It's generally accepted one. It is based on meter, kilogram, second, ampere, Kelvin, candela. So it is based on the decimal arithmetic method. So it is of greatest advantage and it's very simple. The three types of units are fundamental units, supplementary units and derived units. So we can look on with each one in detail. So fundamental units are nothing but length is having the unit as meter, mass as kilogram, time, seconds, temperature, Kelvin. For electric current it is ampere and for luminous intensity it is candela. So meter, we have various definitions given by many scientists and the accepted ones are being given over here. It is a length equal to 1, 650, 763, 73 wavelength of light emitted in vacuum by the atom of krypton 86 on its transition between the levels 2p10 and 5d5. So in 1982, the definition of meter was changed to the distance the light travels in 1 by 299, 792, 458 of a second. For the measurement, light from a helium neon laser illuminates iodine, which fluoresces at a highly stable frequency. Similarly, the definition for kilogram. The standard kilogram is defined in terms of platinum iridium mass maintained at very accurate conditions at the International Bureau of Weights and Measures in Sevres, France. The second is the duration of 9, 192, 631, 772 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. I'm just making it fast with all those things because these are very basic ones. Then the definition for ampere, it is that constant current which maintained in two straight parallel conductors of infinite length of negligible cross section and which is placed 1 meter apart in vacuum would produce between these conductors a force equal to 2 into 10 power minus 7 Newton per meter of. The Kelvin is a fraction of 1 by 273.16 of the thermodynamic temperature of the triple point of water. And finally, candela is the luminous intensity in the perpendicular direction of a surface of 1 by 6 lakh meter square of a black body at the temperature of freezing platinum under a pressure of 1,1325 Newton. So with this, the fundamental units is over. Next, moving on to the supplementary units. So the two supplementary units are plane angle and the solid angle. So plane angle, the unit is radian, and for the solid angle it is a steradian. So radian, it is related to a 2D, and for steradian it is a 3D. Radian is the plane angle subtended at the center of an arc of unit length at unit radius. So it is a plane angle. Whereas steradian, it is a solid angle subtended at the center by unit area of a spherical surface at unit radius. So that is a plane angle, radian, and for solid angle it is a steradian. And finally, coming on with the derived units. So they are derived from the basic fundamental units and the supplementary units. So the three categories of the derived units are mechanical units, electrical and magnetic units, and the thermal units. So under mechanical units can be units for either force, pressure, stress, weight, torque, acceleration, velocity, density, and it goes on. Similarly for electrical and magnetic, power, energy, resistance, electric field strength, capacitance, magnetic field strength, magnetic flux density. So I just listed a few of them, but still there are more. And for thermal units, like units for specific heat capacity, latent heat capacity, sensible heat, and many more are there. So next, let us move on to the topic standards. A standard, it is actually a physical representation of unit of measurement. So it is a known, accurate measure of physical quantity. So standards are used to determine the values of the physical quantity by the comparison method. So as we move on, it will be more clear. Depending on the functions and applications, different types of standards are there. So the 4 different types of standards are internationally accepted one, primary, secondary, and the working standards. So let us look on to each one. So the international standards, it's been defined by international agreement, and these standards are periodically evaluated and checked. It represents units to closest possible accuracy, and it is not available for ordinary usage like measurements. So it is the internationally accepted standards, and it is based on an international level. The next one are the primary standards. So it is like for a single country. So main function is calibration and verification of the secondary standards. So that which will come after the primary standards. So to verify them, they make use of the primary standard. So primary standard is maintained at a national standard laboratory. So for India, the National Physical Laboratory is at Delhi. This standard is ultimate reference standard with more accuracy. So as the secondary standards are being verified using the primary is being verified using the international. So next, coming to the secondary, it is the basic reference standard maintained by a particular industry. So each lab can have its own secondary standards to national lab for calibration and comparison against the primary standard. So the last one coming into the working standards. So it is for a single lab. Can be either in a school level or a college level. We are going to maintain a standard and we are going to check using them. So the main tools of a lab. It is used to check and calibrate the lab instruments for accuracy and performance. Example, the plug gauges or thread gauges or whatever may be the gauges, or let it be your vernier calipers, all those things. It's used to check the bore diameter of a bearings. So all those instruments. So this is with the standards. So the next part will be the measuring instruments. So the measuring instruments, we are having the classification. So before going on to it, let us look on to it. What are measuring instruments? There are a large number of instruments. Example, time constant measurements, like weight measurements. So weight cannot vary for an object. I mean for a non-living thing. For living thing it will vary. For time varying measurement, the pressure will vary depending on the time. So output of the time varying variables cannot be read on a scale and pointer. Thus, there are many instruments with different principles. So based on the necessity and the requirement, the instruments are being classified into various categories. So based on them, we are having 7 different classifications. So it's based on the application and the mode of operations. The 7 different categories are deflection and null type instrument, analog and digital instruments, active and passive type instruments, automatic and manually operated instruments, absolute and secondary instruments, contacting and non-contacting instruments, and the last one is the intelligent instruments. So let us look on to each one in detail. So deflection and null type instrument. So this we have seen many times even in the school life, and also We have done experiments with it. So let us look on to it in detail. In deflection type, the measured quantity generates the effect, and hence the deflection of the pointer is going to occur. Example, like a weight measurement by a spring balance. To be more simple with it, we have done this spring balance experiment in the school itself. When you are going to look on to the null type, it will be more clear with the deflection type. So nullifying effect causes the measurement of the weight. Example, like a beam balance. So all these we have seen even in the grocery shops or roadside shops, where they will be making use of the weight stones on the one pan, and on the other pan they will be keeping the weight of the vegetable or the fruit what they are going to buy, and then they look on to that there is no deflection in the pointer. So null type is more accurate than the deflection type. In the observer view, the deflection type is more convenient. So the deflection type, nowadays straight away whatever is the weight of the grocery or the food you are getting, the pointer will go and indicate the weight of it. Sensitivity of the null type is high, as a null pointer covers small range around the null point. So can look on with a very simple examples. So the deflection type, we are having the spring balance, where the scale and the pointer will show whatever may be the weight is being attached to it. Whereas in the null type, when the pointer is going to show the 0, it indicates that it's equal on the either side. This is what the ordinary people who are having the roadside shops will be making use of to give the vegetables or the fruits. Next, analog and digital instruments. So this is a very simple one. So output varies in a continuous manner and takes infinite values in a given rate. So analog readings, whereas digital readings, straight away the digital answers will be getting. Output varies in a discrete manner, takes finite values in a given range. So the advantage is that it's direct and precise readings. Digital signals are noise resistant during the transmission. So digital circuits operate on low voltage and it is suitable for digital computer processing. Coming into the active and passive type instruments. Active instruments, quantity that is being measured activates the magnitude of some external power input source to produce measurement, which means that apart from the measuring quantity, external energy input source is being present. So when we are going to look on to the example, it will be more clear. So apart from the quantity what we are going to measure, external energy input source is being present. So the input is going to activate the magnitude of some external power input and it's going to produce the measurement. So the best example is liquid level indicator, and for the passive, output is being produced entirely by the quantity being measured. Example, the pressure gauge, which means that based on the pressure, the gauges will like expand or it's going to contract depending on the pressure. So resolution is less and cannot be increased easily. In active, resolution is controlled by adjusting the magnitude of the external energy input. So this is with the example. For the active type, we are having the liquid level indicator, and for the passive type, it is the pressure gauge. So here in the liquid level indicator, we can see that to find out what is the level of the liquid, we are having a float in turn which is being connected to an external power input. So based on the level of the liquid, the float which is being fitted to this pivot arrangement will vary. The float is going to vary, which is attached to a needle-like pointer, and this output I mean that the output from the float will activate this external power input, and because of this we'll get the output reading. So this float is used to find the level of the liquid, but this in turn is going to activate the external power input, and finally the output reading will be shown to tell us what is the level of the liquid. Whereas here, coming into the pressure gauge, to find out what is the pressure, so this is like a liquid or a gas is being filled inside a cylinder. So to find out what is the pressure that is being created because of this liquid or gas, straight away a piston cylinder arrangement. This piston cylinder by means of the spring attachment is being attached to the scale and pointer. So when the liquid or gas is going to be increased in this cylinder, this piston is going to move to or fro based on the content over here. So this movement of the piston will change the reading of the pointer on the scale. So this will straight away give us the pressure that is going to be exhausted over. Next, moving on to the advantages. So in the active, the resolution is controlled. Design is complicated, hence it is costlier. This is a disadvantage. The passive one, there is no control over resolution, which is a disadvantage, but the design is easy and hence it is a cheaper. The next type is automatic and manually operated instrument. The word itself indicates that automatic one. So straight away when you are going to switch on the machine, the measurement is going to be carried out and the instrument will do the readings. Whereas in the manually operated one, always needs a human service behind it. So in manual, human service is required. In automatic, the auxiliary devices are incorporated in the instrument to dispense with the human operator. Example like an electronic weighing scale. Whereas in the beam balance or the spring balance, what we have seen, we have to stand beside it and we have to note down the reading. Coming into the absolute and the secondary instruments. In the absolute one, it gives value of measured quantity in terms of constant of the instrument and their deflections only. Example like the tangent galvanometer, which is rarely used. The secondary one, pre-calibrated by comparison with the absolute instruments, and output is determined by the deflection of the instruments. So without the calibration of the instrument, deflection is meaningless. So always we need the calibration that is to be done with the secondary one. So deflection will be meaningless, and this is widely being used. When coming into the contacting and non-contacting, it's a very simple one. For example, the best example is for temperature measurement. When we are going to make use of the thermometer, we will be having the thermometer in contact with the measuring medium. Whereas when you are going to consider the pyrometer, the instrument need not be in contact, so we can measure the temperature by placing the pyrometer even at a distance. And coming into the last one, intelligent instruments, the term itself indicates that these are the very modern instrument. It incorporates a microprocessor. The microprocessor based instruments facilitates the programmed signal processing and applications of data manipulation algorithm to measure variables. So it is like the recent methodologies where even in many cases the system controlled instruments can be there and a software can be installed in them, and straight away we can get fast and more accurate readings using these intelligent instruments. The facilities or the advantages are that selection of time constants, linearizing the non-linear outputs. Remote can be used to operate the instrument, so we need not go and operate them manually. Final output is in the desired form and units. So whatever the units we desire, we can activate it accordingly. Programming is possible to correct the output. So a part of the first unit is being covered until this. So we have seen what is a generalized measurement system, and we have seen the 6 major parts of it, and then an example of filled thermal system. Then we have seen with the units and standards. So what are the fundamental units, supplementary units, and the derived units. And then coming on with the standards, we have seen with the 4 different types of standards: international, primary, secondary, working. And coming into the measuring instruments, we have looked on with the 7 different types of instruments like analog, digital, active, passive, and the last one you have seen with the intelligent instruments, and contact, non-contact, absolute, secondary, all those things. The next part will continue with the next class. So for this session, this is it.